we have learned all those three methods. In this video I am going to teach how can we find out the center of gravity of a composite section. Find the center of gravity. Now this is our problem that had been given. For example, in an exam a question comes out verbally and even the shape is not there. I can teach you how you can draw the shape. Now it is written here. I will read the question and I will also tell you how can you draw the figure. Now it is written here, find the center of gravity of a 100. Find the center of gravity. We have to find the center of gravity of 100 mm, 150 mm, 30 mm T section. Now this word T section tells us this section will be a T shaped. Means I can say that a shape like this. Okay. Now the first dimension is always horizontal. So in this T section, which section is horizontal? Definitely this. So I can say that this is 100 mm. The second dimension is always the vertical one. So my vertical one will be 150 mm. So I can say that my height, total height will be total height. Remember that 150 mm. Okay. Now the third dimension tells us about the thickness. Means this thickness will be how much? 30 mm. And not only for the flange, it will also tell us the thickness of web as well. Means this, make it such a way that it's like this. Okay. Now we have our figure. We are going to find out the center of gravity of this composite section. Okay, I will redraw this figure to make it more clear, and I will try to find out the center of gravity of this composite section. Okay, now I will make it shorter. Now this is our statement. Okay, I am going to find out everything here so that it should also show a bit of fair work. Now I know my dimensions. I can redraw this figure as like this. Okay, this is my figure. Okay, now I am dividing the upper section and lower section. I knew from above figure that whole length is. I knew from above figure that my whole length was 150 mm. If I minus 150 mm minus 30, no, I don't need to do that. Minus 30 actually. So I can come across about 120. So I can say that this height will be 120. Okay. Okay. So I can say that this height is 120 mm. Okay. And now this thickness will be differently. It is given 30 mm. So this section is 30 mm by 120 mm. Okay. The second thing, now the above section is, I knew my above section, it is 100 mm by 30 mm. It is already given. It is 100 mm and this is 20 mm. Okay, so this, I can say that this is my first section and this is my second section. It's quite simple. So what will be my first step for solving this? Now remember that if you are solving this question in examination hall or in a register, so that's why I have made this small piece of paper. So you can draw this figure at one side and you can write the calculation on other side. Now you will write that the calculation of section 1 means you can write like this. Section 1. Your section 1 gives you area 1. The area 1 will be 100 by 30. Oh, I have made a mistake. It's 30. 100 by 30 is equal to 3000. And I haven't drawn x's. That was I have done. Now remember that my x's will be here definitely. Okay, here and definitely will this with this age. Okay, now I knew I am going to find out this x. X1. I knew x1 will be from in this direction. Okay, but this x1 will be of this figure, means horizontal. From this point to the center of this will be x1 will be equal to 100 by 2. It is equal to 50 mm. This is quite clear. I have already explained you about the geometrical figures. Okay, now this is our x1 and this y1 will be, first figure will be, now this is 120 distance. Now remember that I have to make, before going towards this center distance of this section 1, I have to add this distance because I have to calculate the center of gravity with respect to my axis. So first this distance, then this half distance. So my total distance above is 120 mm plus the center of gravity of this particular section will be 30 by 2 because vertical distance is 30 mm. So this distance will be 135 mm. 135 mm actually. Okay. Now likewise for section 2, I am not going to explain it more meaningfully. Now I can draw this figure around here. Let's make I will make it layer, and for my section 2 you can write this section 2. For section 2 my A2 will be equal to 120 into 30. This will be area of my second section, and my x2 will be equal to, remember that same concept as I given in section 1. My axis is this. Okay, so initially I have to hit this distance. Though this distance will be 100 divided by 250. So up to this point I will be 50, and I have also minus this distance, so I can get this. So 50 minus 50, it's 35. So I got my distance is equal to, this is 35 plus the section width of the second section is 30 mm. So 30 by 2 is definitely 50 mm. It's a symmetrical section, so it is equal to 50 mm. Yes, it's 50 mm. Okay, now my y2. What will be my y2? My y2 quite simple. It will be 120 by 2. Very good. 60 mm. Now there is a next step. I won't solve the next step. It's on to you. It's quite simple. After you have find out these values of section 1 and section 2, a1, x1, y1, you can find out the value of x bar, means the center of gravity of this composite section will be from this line x-axis and y-axis. From this line x-axis, from this side y-axis, actually it will be in axis, since x is equal to a1 plus a1 x1 plus a2 x2 whole divided by a1 plus a2. Okay, so in y direction the y bar will be equal to, simple, y bar is equal to a2 y1, it will be a1 y1 plus a2 y2 and whole divided by same a1 plus a2.